Hello, little freshies. It's Miss Mange and Mr. Martineau.
Hello.
At the House of M in Connecticut. You're doing a constant speed lab, and we want to show you how to graph. We would do this in school live with you, but we're not in school. So if you don't have graph paper, you can still graph. You can use lined paper, you can use white paper, but you definitely need a straight edge, and you need 4 different colors of either colored pencils, markers, highlighters, but 4 different colors for the graph lines. So if you don't have graph paper, this is what we're going to do. If you have graph paper, use it. If you don't, get 2 pieces of lined paper. And this is going with the constant speed lab, lab 1B. Turn it so that your lines are vertical and get a straight edge. And start out with making the x-axis. And we don't want a little tiny graph, so don't make a tiny graph. Can you see that?
Yep.
All right, so make an x-axis, make a y-axis, and it's kind of nice if you use lined paper because you can use the lines as a guide. We have arrows on the ends of our axes to show that they go on, they're raised, they're not line segments. This is our x-axis. If you want to label it x, that's fine. This is our y. You don't have to label them. What you do have to label is time. And I know my handwriting is abominable. And time is in seconds. Time is the independent variable. We can set the time that we want the experiment to run. So we control this. It's the x variable. And on the y-axis, we have distance. And in this lab, we had people walk down the hall and we measured in meters. So we have distance on the y, it's the dependent variable. The last part you need to this is a title. You can name it Lab 1B if you want, constant speed or exploring constant motion. If you want to call it distance versus time, you can. So if you use the variables, it's always y versus x. Do not give it a cutie name like my speed graph. You used to do that in 2nd grade. It's not 2nd grade anymore. The next thing you need are intervals. This is our origin. It is 0, 0. Use these lines as your intervals. Now, I'm not going to tell you what to number them. You need to look at the time data and decide how to break up your x-axis, but you have equal intervals here. So for example, let's say I wanted to go up in 0.5 seconds. I am deciding to go every other 1. Skipping, this is 1.5. Skipping, this is 2.0. I'm not telling you to do it like this. This is how I'm doing it just as an example. So I want you to notice if this was money, this is 50 cents, $1, $1.50, $2, $2.50, $3. That means if this is 50 cents, this is 25 cents, 0.25. I'm just not going to write it. This would be 75 cents, 0.75. So if the decimals are confusing, think of them as money. Okay. How do you get equal intervals on your y-axis? Get a 2nd piece of lined paper. Line up one of the lines with your x-axis, and you can draw in intervals using the lines. You want to use a ruler? Use a ruler. But if you don't have a ruler, you can use paper to do this. Okay, and you can keep going. And then you have to put some numbers here. We measured at 3, 6, 9, and 12 meters. Those would be the best numbers to use, but we're not going to put them here, 3, 6, 9, 12. It's too small. So maybe I'm actually going to go 1, 2, 3 meters, 4, 5, 6 meters, 7, 8, 9 meters, 10, 11, 12 meters. And if you wanted to do one more, just because
Because you can.
Because, yeah, to
because
finish
it's
it.
there.
All right. So you have to graph 4 different graph lines, one for each of the teachers that walked. Time is your x, distance is your y. When you graph a coordinate pair, and I'm making one up, let's just say we wanted to graph 1.0 comma 6. This is our x, this is our y. We always start at the origin and go over first on the x, and it's a positive number, so we're going to 1.0, and we're going up to the 6. And if you want to, if you don't have graph paper, use the ruler so that you can see where to put a data point. So each teacher will have 4 data points, and I'm just randomly drawing things in. Each teacher will have 4 data points. Maybe this is Mr. Marcotte's line, okay? After you put in the data points, you have to draw what we call a best fit line. It's not a line that connects the dots. It's a line that cuts through the data so that you have the same number of points above the line and below the line. You might not actually go through any of them. The point you have to go through is the origin. So what you would do is line up your ruler with 0, 0. And what I like to do is put my ruler on the side so that I can see all of the points if I stand above it. If I draw my line here, that is not a good best fit line. They're all above. If I draw it here, that's not a best fit line. They're all below. So I want to find the spot where, well, on this one I have 2 below and 2 above. And the only point I have to make sure I go through is the origin. I'm going to put my best fit line in, and I should have done it in red because I made my data points in red. So you could sketch it in pencil. I'm not using pencil because I don't think you'll see it.
No, you won't.
That's why I'm using Sharpie. But you might want to go pencil first. This is a good best fit line because we have 2 below about the same distance away as the 2 above. And then you're just going to graph the next person. I don't know where those data points will be. I'm just making stuff up. But you do the same thing again. Use the data. You make a best fit line. It has to go through the origin. I don't know. So kind of move the ruler around a little bit. You must go through the origin. That's not a bad best fit line. So I'm going to have 4 lines on here. The last thing that you definitely need is a key. You have 4 different graph lines. You could do something like this. Maybe my red line is Mr. Marcotte. Maybe my green line was Mr. DeRezzo. So you definitely need a key.
A key where? Here.
A key here. Okay.
Also, that green one, none of the points go through your line, but that's okay. It doesn't mean it's a bad line.
No.
It's a good line because you have 2 below and 2 above. Some kids get worked up. They think they're wrong. Well, the data's bad because none of them, my line isn't on any points. And the fact of the matter is, it doesn't matter. This line is now the only one that matters.
What we're really looking at is the trend of the data. What is the data doing? As time is getting bigger, so is distance. That's what we're looking at. So it's a best fit line because it's the line that best describes what the data is doing. And time is getting bigger and distance is getting bigger. It's okay if you don't have any on the line. Or maybe they'll all fall on the line, and that's okay too. Anything else you want to add?
No, that's it.
That's it?
That's it.
All right. So we will talk more about this live in class. And wait,
what?
Yeah,
I got my socks on.
All right, guys. Thank you.
Bye.